Okay, I want you to do a quick mental exercise with me. Picture a software development team, the standard modern setup. What does that look like in your head?
The classic image.
Yeah.
It's probably an open plan office or maybe a Zoom grid these days, but you see sticky notes. You definitely see a whiteboard.
Right, with columns. To do, in progress, done.
Exactly.
You see the stand-up meeting, everyone kind of awkwardly saying what they did yesterday. You see sprints, and, fundamentally, you see humans at keyboards, taking out logic, line by line.
And that's been the mental model for, what, at least 20 years now?
Mm.
Humans write the code. Teams plan the work in these 2-week chunks. Quality gets checked in stages. And then eventually, after everyone signs off, we deploy.
But here's the thing that really struck me in the research we're diving into today. The source material argues that this entire model, the sprints, the staged approvals, the whole human-centric pacing of it all, it's actually just a massive coping mechanism.
The coping mechanism, that's a heavy way to put it, isn't it?
It is. But the argument is that we built all these structures, Agile, Scrum, Kanban, specifically because we humans are slow. We're the bottleneck. And the question we're asking today is, what happens to that model when the thing doing the coding isn't slow anymore?
That is the core question. We're looking at a shift that the source material describes as moving from assistive AI to autonomous loops.
And we need to be really specific here because I feel like every time we talk about AI and coding, people just think Copilot. They think, oh, cool, my autocomplete got smarter.
Exactly, and that is what we need to move past today. We aren't
Sure.
talking about a developer having a faster typewriter. We are talking about AI becoming the native operating layer of the software development lifecycle.
Native operating layer. Okay, break that down for us because that sounds a little like buzzword bingo, but I know you mean something very specific.
I do. Think of it this way. Right now, AI is a participant. It's sitting next to you. It's offering suggestions. The shift we're discussing is where AI becomes the system itself. It's not just writing the code. It's running the whole loop, creating, testing, deploying, observing.
So our mission for this deep dive is to look at the mechanics of this. We want to strip away the robots are taking over hype and really look at the operating model. I mean, when the system handles the execution, what happens to the professionals, to the service firms? And frankly, does Agile even make sense anymore?
It's a fundamental restructuring of how software gets delivered. And to understand it, you have to understand why we work the way we do now.
Let's start with that coping mechanism idea I mentioned, the death of the human constraint. The sources make a really bold point about Agile and Kanban here.
It is bold, but if you step back, it's logically sound. Think about why Agile even exists. Why do we have sprints? Why do we have WIP work in progress limits?
Usually to keep things from turning into chaos, right? To keep the team focused and stop management from changing their minds every 5 minutes.
Right, but focused on whose timeline? It's organized for humans. Agile is a response to a very specific constraint. Human throughput. Humans are the slowest, the scarcest, and frankly, the most error-prone part of the system.
That's a bit harsh, error-prone, but I guess the data supports it. We get tired, we make typos.
It's just biological reality. We have context switching costs. If I interrupt you while you're deep in the code, it takes you, 20 minutes to get back into the flow? That's why we need ceremonies like sprint planning, is to coordinate our brains. We need story points to guess how long it'll take a human to type and test something. The whole framework is designed to manage human slowness.
So the argument here is that when you remove that human slowness, the framework itself just stops making sense.
Precisely. The source material highlights this as the major disruption. If an AI system can generate the code, write the tests, provision the environment, and deploy the change in one continuous loop, suddenly a sprint just stops being a logical unit of time.
Because the machine doesn't need 2 weeks to plan a batch of work, it just does that.
Right. It's not that Agile fails or was wrong. It just becomes insufficient. It was the primary organizing principle for a human speed world. We are entering a machine speed world.
This brings us to a concept in the notes I saw called the autonomous delivery loop. It's described as a shift from a linear line to a continuous circle. Can you walk us through those steps? How is it different from what a really good DevOps team does today?
So in a traditional DevOps setup, I write code, I push it, and a server runs some tests. But I, the human, am still the driver. I'm the one pushing the button. In this autonomous loop, the human role shifts way up to the very beginning. Step one is intent is expressed.
Intent. So is that me saying, I want the login button to be blue, or is it something more complex?
Ideally much more complex. Intent is about business outcomes. I want to add a feature that allows users to export their data to CSV, subject to these privacy constraints. That is the intent.
Okay.
Once that's defined, the system takes over. Step 2, change is generated. The AI writes the code. Step 3, tests are created and executed. And this is key. The AI writes the tests for the code it just wrote based on the intent you provided.
That feels like grading your own homework, doesn't it?
It does.
Is that safe?
That is a huge area of debate, and we'll get to governance later because you're right to be skeptical.
Yeah.
But strictly on the workflow, the system writes the code, writes the test, runs the test. Then step 4, deployment is prepared. Step 5, behavior is observed in the wild.
And the steps?
Adjustments or rollbacks. If the system sees error rates spike, it reverts the change automatically. It's a self-correcting loop.
It sounds incredibly fast, but is this all theoretical, or is this actually starting to happen?
It's starting to happen. The author of the source material actually shared this great personal anecdote. They used an AI-native environment to build a fully deployable application in less than 30 hours.
30 hours.
Yeah.
From zero.
From concept to a live app. And here's the kicker. They didn't write the code line by line. Their role was just specifying the intent and then validating the outcomes. The system handled all the rest, the generation, the testing, the configuration, everything.
That's the shift right there. They weren't coding in the traditional sense. They were steering.
Steering is the perfect word.
Mhm.
And that changes the whole unit of delivery.
Sure.
In the old world, the unit was a user story or a ticket that took a few days. In this new world, the unit of delivery is just a validated change. It could be 10 tiny changes an hour.
A validated change. It feels much more fluid, but I have to play the voice of the listener here. I can hear the anxiety creeping in. I mean, if the system does the coding, the testing, and the deploying, what do the humans do? If I'm a junior developer listening to this, am I obsolete?
It's the natural question. And I'm not going to sugarcoat it. The role changes drastically. But the sources are actually quite optimistic here. It's not about irrelevance. It's about redefinition.
Redefinition. Unpack that. Because redefinition often sounds like corporate speak for you're fired.
Fair point. But think about supply and demand. When execution, the act of typing code and running tests, becomes cheap, fast, and continuous, the economic value has to go somewhere else. It shifts upstream.
Upstream meaning closer to the what and the why rather than the how.
Exactly. We are moving away from writing routine code or manually crafting test cases or just managing the mechanics of JIRA tickets. We are moving toward defining intent, designing system boundaries, and reviewing diffs or changes.
There was a quote in the source that I circled 3 times. Judgment becomes the scarce resource, not syntax.
That is the core truth of this entire shift. Syntax is now a commodity. The AI knows the syntax better than you do. It knows every library, every API. But judgment, knowing if the code actually solves the business problem, knowing if it's safe, knowing if it's ethical, that is the premium skill.
So let's get concrete with titles. If I'm a developer today, what am I tomorrow? The source suggests supervisor of systems.
Right. Think of it like a construction site. Today, you are laying the bricks. Tomorrow, you are the architect standing there with the blueprints, watching the robots lay the bricks. Your job is to spot when a robot starts building a wall over a window and hit the stop button.
You're managing the output, not generating the input. What about QA? Quality assurance.
QA undergoes perhaps the biggest shift. Traditionally, QA is about verification checking. Does the button work? In an autonomous loop, the system checks if the button works. The human role moves to quality strategy.
Quality strategy. That sounds a lot more high level.
It is. You are designing the nets that catch the bugs. You aren't catching them yourself with a butterfly net. You're asking, what are the edge cases the AI won't think of? How do we test for bias? How do we test for complex user behaviors? You are auditing the machine's testing logic.
And engineering leaders, the people who manage these teams.
Stop being facilitators of ceremonies. They stop asking, did everyone stand up today, or did you move your ticket? They start governing throughput and risk. They're managing a factory floor now, not a craft workshop.
That is a profound mental shift. Factory floor versus craft workshop. It feels a little less romantic, honestly.
It might be less romantic, but it changes the economics entirely, which brings us to the business side of things.
Right, let's zoom out. We've talked about the individual. What about the industry? Specifically, the massive industry of software services, the outsourcing firms. This feels like an existential threat to them.
It's extremely disruptive.
Mm.
Think about the business model of a traditional outsourcer or a consultancy.
It's butts and seats, right? The time and materials model. I pay you for 100 developers, you give me 100 developers, I pay for their hours.
Exactly. It's based on headcount, selling capacity. But if AI absorbs the execution layer, if AI generates the code in seconds, selling human labor hours just loses its value.
Because I don't need 100 humans to write the code anymore. I might need, 5 humans to supervise the system that writes the code?
Right. If you're a client, are you going to pay for 40 hours of work if the AI did it in 4 minutes?
No way! The billable hour is dead in that scenario.
So the client stops asking, how many devs do you have? And starts asking, how fast can changes safely reach production? Or what are your guarantees around operational risk?
The conversation shifts from effort to outcome.
And that forces these service firms to pivot hard. They have to stop selling staff and start selling managed delivery systems. They have to say, we will run the machine that builds your software, not we will hire the people to type it.
That sounds like very bad news for countries that have relied on exporting talent based on volume. We've seen entire economies built on this volume advantage.
It creates a crisis for that volume advantage, yes. For a long time, if you had thousands of engineers who could code at a decent rate, you had an economic moat. But when delivery scales through systems, volume is no longer a durable advantage. One expert with a system can outproduce 20 average coders without one.
So what becomes the new advantage if it's not volume?
Depth. Depth of engineering judgment. Governance capability. Trust. The next phase favors ecosystems that invest in AI operations and systems thinking. It's quality over quantity, but on a global economic scale.
Okay, I want to pivot to the dark side of this, because we're painting this picture of high-speed, autonomous, continuous delivery. It sounds efficient, but it also sounds dangerous.
Dangerous how?
Well, if the robot is writing the code and testing the code and deploying the code, who stops it from nuking the database or deploying a massive security hole?
And that brings us to maybe the most important theme in the source material. Governance.
The boring word that saves all our jobs.
It is only boring until you crash production. The source emphasizes that we're not entering. It gets harder because of the speed and the opacity. When a human writes code, there is a paper trail of thought. You can ask Bob, why did you write this function this way? And Bob will tell you. When the machine generates it, that context is different. You have to ask, who approves this change? And when?
Right. If the loop is continuous, do I have to click approve every 30 seconds? That just sounds miserable.
Exactly. That's alert fatigue waiting to happen. So you need automated governance, but then you run into the silent failure problem.
Silent failure. That sounds ominous. Define that for us.
A silent failure is when the application works technically. It doesn't crash.
Yeah.
The screen loads. The button clicks. But the logic is flawed in some subtle way.
Like what?
Maybe the AI optimized a pricing algorithm. Now it's selling everything for $0 because that maximizes sales volume.
Oh wow. So the compiler says this code is valid, but the business logic is catastrophic.
Precisely. A unit test might not catch that, especially if the AI wrote the test to match its own flawed code. The system could be confidently wrong at a massive scale.
Yeah. That is terrifying, because with humans, we usually catch that in a code review or just by, chatting about it.
Which is why the source argues that these aren't technical problems, they're operating model problems. Organizations that treat governance as an afterthought, something to bolt on later, they'll actually slow down. They will break things so often that they'll lose all the speed gains.
So the companies that win will be the ones that design governance into the loop from day one.
Yes. The supervisor of systems role we talked about, a huge part of that is defining the guardrails so the system can't break things silently. You're building the fence, not walking the dog.
This all feels very grounded. We aren't predicting the singularity here. So let's look at the timeline. The sources give us a grounded prediction for the next 12 to 18 months. What should we actually expect to see?
The yes list is pretty clear. Expect a significant increase in AI-generated code. That is happening now, and it will accelerate.
Okay, that's a given.
Expect QA and testing to really collapse into continuous validation loops. The idea of a separate testing phase at the end of a sprint will start to feel very old very fast. If you're a QA tester manually running scripts, you need to upskill immediately.
And what about team sizes?
Smaller human teams supervising much larger volumes of change. You'll see these small squads, maybe 3 people, doing the work that used to take a department of 20.
Wow. And what should we not expect? Give us the reality check.
Do not expect broad, unsupervised autonomy for core or critical systems. You aren't going to see a major bank letting an AI deploy updates to its main ledger without a human in the loop.
The regulators would have a heart attack.
Exactly. Regulatory acceptance of opaque delivery is not happening anytime soon. And also, don't expect legacy systems to magically become self-healing overnight. This applies mostly to new, modern stacks. If you have a 30-year-old mainframe, the AI isn't going to magically refactor that into a microservice loop next week.
So there's a divergence between greenfield new projects and brownfield legacy stuff.
A huge divergence. And managing that gap is going to be messy.
There is a concept in the contusion called Chapter 2. I really like that framing.
Yes, Chapter 1 was acceleration. Everyone getting Copilot, everyone typing faster. That's where we are now. It was all about individual productivity. Chapter 2 is alignment.
The alignment.
Success in Chapter 2 comes from aligning decision-making and accountability. It's not about the tool. It's about how you align your organization to let the tool work safely. It's about organizational structure, not just buying software licenses.
So to wrap this all up, let's recap. We are moving from a world where humans handle the phases to a world where humans supervise the systems.
The SDLC isn't disappearing. It's just being absorbed by the machine.
And for everyone listening, whether you're a coder, a manager, or even a client buying software, your value proposition is shifting. It is no longer about your ability to execute manual work.
It's about your judgment, your ability to define intent.
That is a huge takeaway. It really turns the hierarchy of value upside down. The doers are less valuable than the thinkers now.
In a way, yes. Or rather, the doing is automated, so the thinking has to get much, much sharper.
Now, before we go, I want to leave the listener with a final thought, something that popped into my head while we were discussing the supervisor of systems.
Go for it.
We talked about how the unit of delivery is changing from a sprint or story to a continuous stream of validated changes. So here are the question. If that's true, how on earth do we measure productivity?
Oh, that's the million-dollar question.
Right, because traditionally we measured lines of code or tickets closed. But if you pay people based on lines of code, the AI will generate millions of lines of garbage in seconds.
And if you pay based on closed tickets, the AI will close infinite tickets.
Exactly. So what does a performance review look like for a supervisor of systems? How do you measure good judgment versus bad judgment before it's too late?
That is going to be the hardest HR challenge of the next decade, measuring the quality of decisions rather than the volume of output.
Something for you all to chew on. As the machines get faster, our metrics might need to get smarter. Thanks for listening to this deep dive into the future of delivery. We'll see you on the next one.